Portable appliance testers, or PATs, are used to test the safety of electrical appliances, including their wiring and insulation. Some PAT have additional features that allow them to test the voltage and load-bearing capacity of electrical circuits. A Fluke 902FC portable appliance tester has a load test function that can apply a variable load up to 25 amps. It also measures voltage and resistance. A Megger PAT410 portable appliance tester has a loop test function that allows you to apply a variable load while measuring voltage. A Martindale FC640 portable appliance tester has a load test function that can apply a load up to 16 amps. It also measures voltage, current, and power factor. Some line voltage testers also have a built-in load to simulate the connected equipment. These testers can test the voltage and verify that the circuit can handle the load. A Klein Tools 69148 circuit breaker finder with load has a 1.5 amp load that simulates a connected device and can help identify tripped or defective circuit breakers. An ideal 61963 electrical tester with load has a 2.5 amp load that can be used to test voltage, continuity, and ground fault interruption, or GFI. If a custom solution is preferred, a tester can be built using the following components: firstly, a variable power supply; secondly, a step-up transformer to convert 120/240 volts to a higher voltage; thirdly, load resistors to simulate the connected equipment; and fourthly, a voltmeter to measure voltage under load. By connecting these components in series, a tester can be created that can apply a variable load and measure the voltage at the load. Note that this requires some electrical expertise to build safely. When selecting a portable appliance tester or line voltage tester, it's important to consider the specific requirements of the application. Factors to consider include the maximum load that needs to be tested, the voltage range, and the accuracy of the measurements. Also, ensure the tester is certified to meet relevant safety standards. Portable appliance testers are designed to perform a variety of safety tests on electrical appliances. These tests typically include a ground bond test, an insulation resistance test, and a leakage current test. The ground bond test verifies that the appliance's metal chassis is properly grounded. The insulation resistance test measures the resistance between the appliance's live parts and its chassis. The leakage current test measures the amount of current that flows from the appliance's live parts to its chassis. The Fluke 902FC is a versatile PAT that can perform all of these tests. It also has a built-in load test function that allows users to simulate the appliance's normal operating load. The Megger PAT410 is another popular PAT that is known for its accuracy and reliability. It has a wide range of test functions, including a loop impedance test, which measures the impedance of the circuit to which the appliance is connected. The Martindale FC640 is a compact and lightweight PAT that is ideal for use in confined spaces. It has a simple user interface and is easy to operate. Line voltage testers with load are designed to test the voltage and load carrying capacity of electrical circuits. They typically have a built-in load that simulates the connected equipment. The Klein Tools 69148 is a popular line voltage tester with a 1.5 amp load. It can be used to identify tripped or defective circuit breakers. The Ideal 61963 is another popular line voltage tester with a 2.5 amp load. It can be used to test voltage, continuity, and ground fault interruption. Building a custom tester can be a good option if specific needs aren't met by commercially available testers. A variable power supply allows adjustment of the voltage and current. A step-up transformer is used to increase the voltage to the desired level. Load resistors are used to simulate the load of the connected equipment. A voltmeter is used to measure the voltage under load. It is essential to prioritize safety when building a custom tester. Ensure all components are properly rated and that the tester is properly grounded. Consult with a qualified electrician if needed. Before testing any electrical receptacle, visually inspect it for any signs of damage such as cracks, loose wires, or corrosion. If any damage is found, do not test the receptacle and consult with a qualified electrician. When using a portable appliance tester or line voltage tester, always follow the manufacturer's instructions carefully. Wear appropriate personal protective equipment, such as safety glasses and gloves. Ensure the tester is properly calibrated before use. When performing a load test, start with a low load and gradually increase it until the desired load is reached. Monitor the voltage and current carefully during the test. If the voltage drops excessively or the current exceeds the circuit's rated capacity, stop the test immediately. After completing the test, disconnect the tester from the receptacle and allow the receptacle to cool down before using it. The results of the test can be used to determine if the receptacle is safe to use and if it can handle the load that will be connected to it. If the receptacle fails any of the tests, it should be repaired or replaced by a qualified electrician. Regular testing of electrical receptacles can help to prevent electrical hazards and ensure the safety of people and equipment. Regular maintenance of electrical systems is essential to prevent electrical hazards. This includes inspecting electrical receptacles, circuit breakers, and wiring for any signs of damage. Damaged components should be repaired or replaced by a qualified electrician. Overloaded circuits can cause overheating and fires. Avoid overloading circuits by using the appropriate size circuit breakers and by not plugging too many devices into a single circuit. Ground fault circuit interrupters, or GFCIs, are designed to protect people from electric shock. They should be installed in areas where there is a risk of water exposure, such as bathrooms, kitchens, and outdoor receptacles. Arc fault circuit interrupters, or RFCIs, are designed to protect against fires caused by arc faults. They should be installed in bedrooms and other areas where people sleep. Using extension cords safely involves inspecting them for damage before use, avoiding overloading them, and not running them under rugs or furniture. Power strips should be used with caution. They should not be used to plug in high-power devices, such as space heaters or air conditioners. Surge protectors can protect electronic devices from damage caused by power surges. They should be used with sensitive electronic equipment, such as computers and televisions. Lightning protection systems can protect buildings from damage caused by lightning strikes. They should be installed by a qualified lightning protection contractor. Electrical safety training is essential for anyone who works with electricity. This training should cover the hazards of electricity, safe work practices, and the use of personal protective equipment. Following these electrical safety tips can help to prevent electrical hazards and ensure the safety of people and equipment. Electrical codes and standards provide guidance on the safe installation and maintenance of electrical systems. The National Electrical Code, or NEC, is the most widely used electrical code in the United States. It is updated every 3 years by the National Fire Protection Association, or NFPA. State and local governments may also have their own electrical codes and standards. It is important to be familiar with the applicable electrical codes and standards in the area where you are working. Electrical inspections are performed by qualified electrical inspectors to ensure that electrical installations comply with applicable codes and standards. Electrical inspections are typically required for new construction, renovations, and repairs to electrical systems. Hiring a qualified electrician is essential for any electrical work. A qualified electrician has the training, experience, and knowledge to perform electrical work safely and in compliance with applicable codes and standards. When hiring an electrician, be sure to check the license and insurance. Ask for references and check them carefully. Get a written estimate before work begins. Be sure the estimate includes all costs, including labor, materials, and permits. Do not allow the electrician to start work until you have signed a contract. The contract should specify the scope of work, the price, and the payment schedule. Monitor the electrician's work to ensure that it is being done properly. If you have any concerns, discuss them with the electrician immediately. Do not make any payments until you are satisfied with the work. Keep a copy of all documents related to the electrical work, including the contract, the estimate, the permits, and the inspection report. If you have any problems with the electrical work, contact the electrician first. If you are unable to resolve the problem, contact the state or local electrical licensing board. The information provided is for general guidance only and should not be considered as a substitute for professional advice from a qualified electrician or electrical engineer. Always consult with a qualified professional before undertaking any electrical work. Additionally, always adhere to local and national electrical codes and safety standards when working with electricity. Improper electrical work can lead to serious injury, death, or property damage. The electrical system in a marine environment is subject to unique challenges due to the presence of water and the corrosive effects of salt. These factors can accelerate the deterioration of electrical components and increase the risk of electrical shock and fire. Therefore, it is crucial to implement specific safety measures and maintenance practices to ensure the safe and reliable operation of marine electrical systems. Grounding is a critical aspect of marine electrical safety. The grounding system provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. The grounding system should be properly installed and maintained, and it should be regularly inspected for corrosion and damage. Ground fault circuit interrupters, or GFCIs, are essential safety devices in marine environments. GFCIs are designed to detect small amounts of leakage current and quickly interrupt the circuit, preventing electrical shock. GFCIs should be installed in all wet locations, such as docks, piers, and boathouses. Wiring in marine environment should be suitable for wet locations and should be protected from physical damage. Wiring should be installed in conduit or other approved enclosures. All connections should be watertight and corrosion resistant. Electrical equipment used in marine environment should be marine grade and should be approved for use in wet locations. Electrical equipment should be properly grounded and should be regularly inspected for corrosion and damage. Overcurrent protection devices, such as circuit breakers and fuses, should be properly sized to protect the wiring and equipment. Overcurrent protection devices should be regularly inspected to ensure that they are functioning properly. Regular inspections of marine electrical systems are essential to identify potential hazards and ensure that the system is operating safely. Inspection should be performed by a qualified electrician who is familiar with marine electrical systems. Maintenance of marine electrical systems should be performed on a regular basis to prevent corrosion, damage, and other problems. Maintenance should include cleaning electrical equipment, tightening connections, and replacing damaged components. Education and training are essential for marina staff and boat owners. They should be educated about the hazards of electricity and should be trained on safe work practices. Emergency procedures should be in place to address electrical emergencies, such as electrical shock and fire. These procedures should be regularly reviewed and practiced. By implementing these safety measures and maintenance practices, the risk of electrical hazards in marine environments can be significantly reduced. Remember, electrical work should only be performed by qualified professionals. Always prioritize safety when working with electricity. The unique conditions present in a marine environment, such as exposure to salt water and constant moisture, can significantly accelerate corrosion of electrical components. Salt water is a highly conductive electrolyte that can promote galvanic corrosion between dissimilar metals. This can lead to the deterioration of wiring, connectors, and other electrical components, increasing the risk of electrical shock and fire. Regular cleaning of electrical equipment with fresh water can help to remove salt deposits and prevent corrosion. Protective coatings, such as epoxy paint or corrosion inhibitors, can be applied to electrical components to provide an additional layer of protection. Using corrosion-resistant materials such as stainless steel or copper-nickel alloys can also help to extend the life of electrical components in marine environments. Bonding is the process of connecting all metal parts of a boat or marine electrical system together to create a common electrical potential. This helps to prevent galvanic corrosion and electrical shock. The bonding system should be properly designed and installed, and it should be regularly inspected for corrosion and damage. Zinc anodes are sacrificial metals that are used to protect other metal parts of a boat or marine electrical system from corrosion. The zinc anodes corrode preferentially, protecting the other metal parts. Zinc anodes should be regularly inspected and replaced as needed. Stray current corrosion is caused by electrical current flowing through unintended paths in the water. This can lead to rapid corrosion of underwater metal parts. Straight current corrosion can be prevented by properly grounding and bonding electrical systems and by using isolation transformers. Lightning strikes can cause significant damage to marina electrical systems. Lightning protection systems can be installed to protect buildings and equipment from lightning strikes. These systems typically consist of lightning rods, grounding conductors, and surge protection devices. Electrical storms can create hazardous conditions in marina environments. During an electrical storm, it is important to take the following precautions. Firstly, seek shelter indoors. Secondly, avoid contact with metal objects. Thirdly, disconnect electrical appliances. And fourthly, stay away from the water. Carbon monoxide is a colorless, odorless gas that can be produced by gasoline-powered engines. Carbon monoxide can be deadly, so it is important to take precautions to prevent carbon monoxide poisoning. Carbon monoxide detectors should be installed in all boats and boathouses. Gasoline-powered engines should be properly maintained and ventilated. Never operate a gasoline-powered engine in an enclosed space. Education and awareness are essential to preventing electrical hazards in marina environments. Marina staff and boat owners should be educated about the hazards of electricity and should be trained on safe work practices. Warning signs should be posted to alert people to potential electrical hazards. By implementing these safety measures and maintenance practices, the risk of electrical hazards in marina environments can be significantly reduced. Remember, electrical work should only be performed by qualified professionals. Always prioritize safety when working with electricity.